Now let's look into another problem where the problem statement says find the single element in a sorted array. So what the problem description says is you are given a sorted array consisting of only integers where every element appears exactly twice except for one element which appears exactly once. So write a program to return the element that appears only once. Okay, so what it is saying is we have been given an array which has all the values sorted basically in the ascending order, and ultimately we have every element except one that appears twice, but there is only one element that is going to appear only once. Ultimately we have to find that element which is appearing only once, and we need to return the value back to the user. So here if you take this example, right, so here 1 is appearing twice, 2 is appearing once, and 3, 4, 4, 8, 8. All other values are appearing twice except 2. So the output is 2 here. Let's just say here 3 is appearing twice, 7 is appearing twice, 11 is appearing twice, 10 is appearing only once. So the output is 10. So here also the same example, here the value is nothing but 3 that is appearing only once. So likewise we will be given an array that are containing sorted integers, every value appears twice. We need to find the element that appears only once. Now let's look at the brute force approach for solving this specific problem, right? So what we can do, every number is appearing twice, right? That means that we can start from index 0 and we can compare every two elements, and if every two adjacent elements are same, then we have found the value. If the every adjacent elements are not same, we found the single element at that particular index and we can return that. So for that we will run a loop from 0 till the very last index, but in each and every step we will be incrementing it by 2 because every value is appearing twice. Now immediately here is where one corner case scenario that you need to think of, right? Whatever the single element that we have, it might be appearing at the last index. That means once we reach this I equal to last index, there is no next value. So there is no next value to compare. So we have to make sure that before we check the two adjacent values, we have to check if we have reached the last index. If so, that means till the index that is before that last index, we couldn't find the single value. That means that the only value that is there at the last index is nothing but the element that is appearing once. So here first what we do is, if I is equal to last index, which is nothing but n minus 1, what we will do, we found the single element and we can simply return array of I or nums of I, whatever the variable that you get your arrays in. If this is not the case, else if the value of I, the value at ith index is not equal to the value at I plus 1th index, then also we found the single element, because since array is sorted and every element is appearing twice, two adjacent values should be same because we are starting from index 0. That means index 0 and 1 should be same, 2 and 3 should be same, 4 and 5 should be same, like that. That means if this condition is not matching, the value at ith index is nothing but the single value. So here once we reach the index 6, right, 6 and 7 values doesn't match, and the index 6 has the single value which is nothing but 4. So in this case we will return array of I as well. If none of these conditions are matching, we will simply move on to the next conditions because the values are matching, and once we reach the last index, if at all if the single element is there, we will return that. So this is the brute force approach for solving this specific problem. Okay, and what is the time complexity? Basically this loop will run for n by 2 number of times, right, which is nothing but order of n. So the time complexity is order of n and the space complexity is order of 1. Why n by 2 number of iterations? Because in each and every step we are incrementing I by I plus 2. So we will only run for, if there are 10, we will only run 5 iterations. If there are 4 elements, we will only run 2 iterations. In that way we will that is the count in which we will run the iterations to find this element that is appearing only once. Okay, so this is the brute force approach. Now here how can we write the better solution, right? That is where binary search is going to come into the picture. How do I know binary searching can be applied here? That is, it is not a traditional binary searching algorithm, but we have to make some tweaks in the binary searching algorithm based on a simple property. So if you observe here, right, here let's take this example only: 1 1 2 2 3 3 4 5 and 5. Every time till we find this element which is appearing only once, if you look at any number, right, till this number, till the element which is appearing only once, if you pick up any value, right, first its occurrence starts at even index and ends at odd index. See, 1 is starting at 0, which is even index, and 1 is ending at index 1, which is odd index. 2 is again starting at index 2, which is even and ending at odd index, and again 3 is starting at index 4, which is even, and here ending at odd index. But once we reach the value which is appearing only once, this value is at index 6, which is appearing only once. But after this, if you see, again all the values will be appearing twice, right? Even after the value which is appearing only once, remaining values will also be appearing twice, right? But after the value which is appearing only once, if you see, whatever the even and odd pattern that we have observed, it will not be satisfying. If you see, first appearance of 5 is at 7, which is a odd index, and again it is appearing at ending at 8, which is a even index. If at all, if we had any other values also, they will be following that pattern. Okay, so based on this pattern, we will restrict our search to either this part or this part. So that is where we will basically calculate the middle, and based on the middle index, whether the value is having is appearing at even index or odd index, and based on this property that I explained, we will be restricting our search to either left part or right part. Okay, once again let me take another example and explain this property once again. Let's just say 1 1 2 2 3 3 4 4 5 5 6 7 7 8 8 9 9 10 10. Now 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So these are the indexes, these are the values. If you see, even odd, even odd, even odd, even odd, even odd, this is even, which is appearing only once. Now after the value that is appearing only once, whatever this property that we had, it is breaking. Now if you see, it is odd even, odd even, odd even, odd even. So basically we can restrict all this into a single search area, and we can restrict all this into a single search area using binary searching technique by calculating the middle and checking if the value can be either in this part or in this part. Value will certainly not be in this part, right? Because values are starting at even index and ending at odd index. That is the reason why our area of focus will be this part. Based on the I'll explain the algorithm, then you will get a better understanding. Anyway, this is the property using which we will be applying the binary searching technique, and we will make few changes to get the solution. Alright, now let's see how can we apply the binary searching technique according to the property that we have discussed previously. What is that property? Till the value which is appearing exactly once, every element that appears twice is going to start at even index and end at odd index. So this is the property. But once the value that appears only once, this property will be violated. Okay, now let's try to apply the binary searching technique, right? So binary searching technique, just like a normal binary searching technique, what we will have start index and we will have end index. what we will do, we will calculate the middle. So middle is nothing but 0 plus 8 divided by 2, which is nothing but 4. So index 4 is what we have gotten. Remember here, this is a even number. Whatever the middle that we have gotten is a even number. That means since this is even, what we can do is we can compare the middle and middle plus 1 values. So here this was our search range and this is the middle. Immediately we will compare middle and middle plus 1. Since middle and middle plus 1 has the same value and middle plus 1 has the same value, that means this property starting at even index and ending at odd index is still not violated. That means the value which is appearing only once will lie on the right part because this property still holds true. So that is the reason why here what I will do, I will increment the start to middle plus 1. So start will be at 5 now, end will be at 8. Again we will calculate the middle, which is nothing but 5 plus 8 divided by 2, 13 divided by 2, 6.5, and if we bring it down, if we floor it, we will get 6. So we have middle here. So here we've gotten middle as 4. Now again we will compare middle and middle plus 1 index values. So middle and middle plus 1 has 4 and 5. That means that they are not equal. Remember that we are not yet sure which is appearing only once, because 4 might have a left value again 4, or 5 can have one more 5 on the right, but we still don't know whether 4 is appearing once or 5 is appearing once. Now since the values are not equal, what we will do, we will update the end with the middle itself. So here whatever the end that we have, we will update it to middle. As a result, we will update the end with middle itself. So end will also be coming to 6. So right now we have the start and end. Start is at 5, end is at 6. Again we will calculate the middle. 6 plus 5 divided by 2, 11 by 2, which is nothing but 5.5. If we bring it down, we get 5. So this only we will got middle. So here if you see, middle we have gotten is a odd number. So here this property holds true. Since we've got an odd number, what we should do, since this is odd number, we will compare middle and middle minus 1 to check if this property still holds true. So 5 we have gotten at index 5 and 5 minus 4. We will compare indexes 4 and 5, which is having value 3 and 3. That means that they are equal. That means the single value will be there on the right of it. So at this point of time, both start and end have become equal. So at this point of time, we will not be running any more condition and we will simply be breaking out. Now if you observe, whatever the value this start index is pointing to, right, this will be the value that is appearing only once. Okay, so that is the understanding that we have here. Once binary searching is applied for all the ranges and restricting ourselves to left or right, in the end, whatever the start index that we have, it will be pointing to the value which is appearing only once. Remember that based on this property, we have searched. If we get middle even number, then we searched even and middle plus 1 indexes to check if this property still holds true. If at all we get middle odd number, we will check middle and middle minus 1 to check if this property holds true. And our single element will always be lying on the section where this property doesn't hold true. That is the reason why we update either start with middle plus 1 or keep end with given middle itself. Okay, not middle minus 1 till middle itself, because including whatever the value we have at middle, any number can be appearing only once. Okay, so that is the understanding. Now let's quickly write the pseudocode for this specific binary searching technique that we have discussed. So what we will do, we will write a function called find single element. It will take the nums array, and immediately what we will do, we will initialize the start index with 0, end index with length of the nums -1, and along with that we will initialize another variable, initialize middle with -1. Now simply run a loop as long as the start is less than end. What we will do, we will calculate the middle, which is nothing but start plus end divided by 2. Once we get the middle right, we will check if this middle is even or odd. If it is even, what we will do, we will compare the middle and middle plus 1, or if it is an odd number, then we will compare the middle and middle minus 1. So here let's write that logic. If mid is even, which is nothing but percentile 2, then basically we will compare middle and middle plus 1th values. So nums of middle is equal to the nums of middle plus 1, or if this is a odd number, if the middle is odd, in that case nums of middle, if it is equal to the nums of middle minus 1, then whatever the starting at even index and ending at odd index is holding true. That means the value which is appearing only once is there after the middle index. That is the reason why here we will update the start with middle plus 1. If this condition is not matching, then the single element is there till the middle index from given start index. So here, if this is not the case, we will simply update the end with given middle itself. Okay, once this condition is satisfied for all the ranges and everything we run, as long as this condition is holding true, in the end whatever the start index that we have, it will be pointing to the value where we have the single element. So we can simply do nums of whatever the start index. Okay, so this is the binary search based pseudocode for finding the value which is appearing only once. And if we want to talk about the space complexity, time complexity, it is order of login since we are applying binary searching technique, and the space complexity will be order of 1. Okay, so remember that here if every value appears twice, the value starts its first appearance at even index and ends at odd index till the value which appears only once, and after that that property is violated. Based on that property, we have made changes to general binary searching technique to get the logic that we have here on the screen. Okay, so now that we have understood the algorithm and binary search based pseudocode as well, let's quickly jump in and write the solution and validate various scenarios.